Greetings, one and all, and welcome to the Open-Handed Classroom. I want to extend a special thank you to you, yes, you, for stopping by. Now, students, before us is a math question, and I got this math question from the 2018 Paper 2 Mathematics BJC examination. Now observe that this question currently is unsolved. This question currently is unsolved, but I assure you that by the end of this video, this question would be completed. The solution would be provided. Okay, I have a question for you, and my question is, are you ready to get started? Are you ready to get started? Then let us begin. The question states the following. Find the value of 2 and 3 over 4 plus 5 and 1 over 8 minus 3 and 1 over 2. I'm going to give you an opportunity to attempt this question on your own. So I encourage you to pause the video, try the question, and I'll see you on the other side of the pause. Okay, now that you have attempted the question on your own, let's consider the question together. Okay, let's consider the question together. The question states, find the value of 2 and 3 over 4 plus 5 and 1 over 8 minus 3 and 1 over 2. The first step that I'm going to encourage you to do is I want us to take each of these mixed numbers, because they are mixed numbers. Take each of these mixed numbers and convert them. Okay, we're going to convert them to improper fractions. Okay, so that's the first step. So convert the three mixed fractions into improper fractions. So let's do that. So we multiply 2 by 4. Okay, we multiply 2 by 4, and that's what is here demonstrated, 2 times 4. And then we add 3. Okay, so, and that's why we have plus 3 here. So 2 times 4 is indeed 8. Okay, and then we just keep the 3 here. And now we add 8 plus 3. What is 8 plus 3? 8 plus 3 is indeed 11. Okay, and notice that the denominator, we got it from the 3 over 4, and it remains the same throughout. It remains the same throughout. Okay, so 2 and 3 over 4 is 11, and 2 and 3 over 4 equals 11 over 4. Okay, so let us look at the other mixed number. Let's look at the other mixed number. We have 5 and 1 over 8. So first we multiply 5 and 8. Okay, that's what we have here demonstrated here. 5 times 8. And then we add 1. Okay, and that's why we have the 1 here. So 5 times 8 is 40. And then we add 1. Okay, so we have 40 plus 1. 40 plus 1 is indeed 41. That is for the numerator. Now, how about the denominator? The denominator we got from the 1 over 8. So we got the denominator from 1 over 8, and the denominator of 1 over 8 is indeed 8, and that remains the same throughout. That does not change. Okay, so let's move on to the final one, the third mixed number that we have to convert into a improper fraction. And so we have 3 and 2 and 3 and 1 over 2. So the first thing we do is multiply the 3 and the 2, and that's what we have here demonstrated. And then we add 1, okay, as demonstrated here. What is 3 times 2? 3 times 2 is indeed 6, and we leave the 1. So we have 6 plus 1. 6 plus 1 is indeed 7. Okay, so for the numerator, the answer is 7. The denominator, we keep the same denominator as 1 over 2, and the denominator of 1 over 2 is indeed 2, and that remains consistent throughout. Okay, so we're done with that step. All of our mixed fractions are converted into improper fractions. Now it's time for the other step. Let us take these, let me erase. Let us take these improper fractions, okay? Let's take these improper fractions and seek to make them in, let's just read the, step. It says here, look at the denominator of the three improper fractions. Okay, so these are the three improper fractions that we found. The denominators are 4, 8, and 2. Okay, so it says look at the denominators of the three improper fractions and find the lowest common multiple of these three numbers. Okay, so the denominators of our three improper fractions are the following: 4, 8, and 2. And so the instruction tells us to find the LCM, or the lowest common multiple of these three numbers. So what is the lowest common multiple of 4, 8, and 2? So first we start by listing some multiples of 4. Okay, so 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and so on. And then we go on and we list some multiples of 8. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, and 8 times 4 is 32. And then we go on to 2 and we list some multiples of 2. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and 2 times 4 is 8, and so on. Now we're looking for the lowest common multiple of these three. So we're looking in this set of numbers, this set of numbers, and this set of numbers, and we're looking for the number that is common in all of them, and not only the number that is common in all of them, but the smallest number that is common in all of them. And that is indeed 8. Okay, that is indeed 8. So 8 is the LCM. So the LCM, right? The LCM of 4, 8, and 2 is indeed 8. Okay, so notice that the lowest common multiple of 2, 4, and 8 is 2. Awesome. Let's move on to the next step. The next step states, find the equivalent fraction of each of the three improper fractions. Okay, so notice that we found three improper fractions that correspond with the mixed numbers that we were given. And the improper fractions that we had were, the improper fractions that we found was 11 over 4, 41 over 8, and 7 over 2. Now, what this question is saying is that what this instruction is saying is that take 11 over 4 and find an equivalent fraction, right? Find an equivalent fraction for 11 over 4. But there's a criteria for this equivalent fraction that you're going to find. This equivalent fraction must have a denominator of 8. Okay, so that's the restriction. The same thing applies for this particular one. It's saying, the instruction is saying, okay, find an equivalent fraction for 41 over 8. But that equivalent fraction that you find, its denominator must be 8. Okay, and the same thing for 7 over 2. Find an equivalent fraction for 7 over 2, whose denominator is 8. Okay, and we can find equivalent fractions by multiplying the numerator and the denominator by the same integer, right? By the same integer. Okay, so we ask ourselves the question, what number, when I multiply it by 4, I am going to get 8? And the answer is 2. So we take 2 and we multiply 2 by the denominator and we multiply 2 by the numerator. 4 times 2 is indeed 8. Okay, 4 times 2 is indeed 8. And 11 times 2 is indeed 22. And then we go on to the next improper fraction and we say, okay, what number, that I need to multiply, what number that I need to multiply by 8 to give me 8? And the answer is 1. So we take 1 and we multiply 8 by 1, and we multiply 41 by 1. And 41 times 1 is indeed 41, and 8 times 1 is indeed 8. Then we go to the third improper fraction, and we ask ourselves the question, what number, when I multiply it by 2, right, what number, when I multiply it by 2, is going to give me 8? And the answer is 4. So we take 4 and we multiply top and bottom by 4. 2 times 4 is 8, and 7 times 4 is 28. Okay? So 22 over 8, 41 over 8, and 28 over 8 is what we got. Okay, so what is the next thing we're going to do? Now we're going to add 22 over 8 and 41 over 8. Then we're going to subtract 28 over 8 from the sum of 22 over 8 and 41 over 8. So let's do that. So notice that we have 22 over 8 and 41 over 8. Let's add them. Okay, so and remember now, 22 over 8 is equivalent, right? That's equivalent to what? It's an equivalent fraction to 11 over 4. Okay? And if we remember 41 over 8, well, 41 over 8 didn't change. 28 over 8, that's equivalent to the fraction 7 over 2. Okay, so don't forget that. Okay, so now let's perform the operation that we have here. So we're going to add 22 over 8 plus 41 over 8. And that's the same thing as adding 11 over 4 plus 41 over 8. Because 22 over 8 is equivalent to 11 over 4. Okay, so when we add these two numbers, when we add these two fractions, note that they have the same denominator, right? And since they have the same denominator, all we need to do is add its numerators and leave the denominator the same. Okay, so let us do that. So we do not need to change the denominator. That remains the same. The only thing we need to do is add 22 and 41. So let's add 22 and 41. 22 plus 41. 2 plus 1 is 3, and 4 plus 2 is 6. So that's 63. So the answer, or the sum of 22 over 8 and 41 over 8 is indeed 63 over 8. Now we're going to subtract 28 over 8 from 63 over 8. And notice that these two fractions, right? These two fractions, they have the same denominator. And what do we do when we are subtracting fractions that have the same denominator? We leave the denominator unchanged, and we just perform the operation with the numerators. So we say 63 minus 28. What is 63 minus 28? We take 1 from the 6, that leaves us with 5, and we put 1 on top, so that's 13 minus 8. 8, 9, 10, 11, 12, 13, so that's 5. And we say 5 minus 2. 5 minus 2 is indeed 3. So the answer is 35. So the result of subtracting 63 over 8, right, and 28 over 8 is indeed 35 over 8. Now we're going to take 35 over 8 and convert it into a mixed number, okay? And we're going to do that by dividing 35 by 8. So let's do that. So 8 is our divisor. Note that 8 is our divisor. And the dividend is indeed 35. Okay, so we say 35 divided by 8. Okay, and the question is, what number that I could use to multiply by 8, what whole number that I could use to multiply by 8 to give me 35? The answer is there's none. But if we multiply 8 by 4, we get a number close to 35. That is a multiple of 8. So we have 8 times 4. 8 times 4 is indeed 32. And then we subtract. We say 5 minus 2. 5 minus 2 is indeed 3. And 3 minus 3 is 0. Okay, so as here it is pinpointed, right? 8 is the divisor, 4 is the quotient, and 3 is the remainder. Now to form the mixed number, to change 35 over 8 into this mixed number, what we're going to do is we're going to take our divisor, and our divisor becomes the whole number, okay? And then we take the quotient, right? We take the, that's my apologies. My apologies. The divisor does not become the quotient. The divisor does not become the whole number. We take the quotient, right? We take the quotient, which is 4, and that becomes the whole number of our mixed number. We take the divisor, and the divisor becomes the numerator of the simple fraction. And we take the remainder, and the remainder becomes the numerator of the simple fraction. So this means that 38, so all in all, we have 35 over 8 equals 4 and 3 over 8. Okay? So now let us use the working in the previous steps to perform the operation between the given mixed numbers. Okay, so let us bring everything together. So now we have 2 and 3 over 4. When we convert that into a mixed number, we got 11 over 4, right? And 5 and 1 over 8, when we convert that into a mixed number, we got 2 and 3 over 4, when we convert it into a improper fraction, we got 11 over 4. 5 and 1 over 8, when we converted it into a improper fraction, we got 41 over 8. And 3 and 1 over 2, when we converted it into a improper fraction, we got 7 over 2. And then we went and found equivalent fractions for 11 over 4, and 11 over 4 equals 22 over 8. 41 over 8 equals, we just bring that down, and 7 over 2 equals 28 over 8. Indeed, the equivalent fraction, indeed 7 over 2 and 28 over 8 are equivalent fractions. The same thing goes for 11 over 4 and 22 over 8. They are equivalent fractions. Okay, good. So now let's add 22 over 8 plus 41 over 8, and then subtract it from 28 over 8. And that's exactly what we did. And when we did that, we got 35 over 8. And then we converted 35 over 8 into a mixed number, and we got 4 and 3 over 8. And 4 and 3 over 8 is indeed the answer to this question. Thank you, and I'll see you in the next video.